Solar power towers have an array of mirrors to focus sunlight on receiver tubes in a central tower.
More than 10,000 tracking mirrors called heliostats reside in a 4-square-mile field where they reflect and concentrate sunlight onto a large heat exchanger called a receiver that sits atop a 550-foot tower. Within the receiver, fluid flows through the piping that forms the external walls. This fluid absorbs the heat from the concentrated sunlight. In Solar Reserve's technology, the fluid utilized is molten salt, which is heated from 500 to over 1,000 degrees Fahrenheit. Molten salt is an ideal heat capture medium because it maintains a wider operating temperature range in liquid state, allowing the system to operate at low pressure for superior and safe energy capture and storage. After passing through the receiver, the molten salt then flows down the piping inside the tower and into a thermal storage tank where the energy is stored as high-temperature molten salt until electricity is needed. Solar Reserve's technology leverages liquid molten salt as both the energy collection and the storage mechanism, which allows it to separate energy collection from electricity generation. When electricity is required by the utility, day or night, the high-temperature molten salt flows into the steam generator as water is piped in from the water storage tank to generate steam. Once the hot salt is used to create steam, the cooled molten salt is then piped back into the cold salt storage tank, where it will then flow back up the receiver to be reheated as the process continues. After the steam is used to drive the steam turbine, it is condensed back to water and returned to the water holding tank, where it will flow back into the steam generator when needed.
The major impediments to widespread deployment of high-temperature solar thermal power plants has been their construction costs. Electricity from solar thermal is several times more expensive than other energy sources except for photovoltaic solar. Nonetheless, proponents of solar thermal claim that this technology will become more cost-effective as it becomes more widely adopted. Heating the interior spaces of buildings and producing hot water account for a major portion of the energy use in a typical home. Traditional methods for solar space heating maximize interception of sunlight in winter, yet minimize it in summer by placing awnings over windows or landscaping with deciduous trees. Also, sophisticated low-temperature solar thermal systems are available to collect sunlight for space and water heating. For example, glass-enclosed flat-plate solar collectors on rooftops have black plates that absorb sunlight and transfer the thermal energy to fluids passing through flow tubes pressed to the surface of the plates. The fluid heated in the flow tubes then goes into the building to warm the interior or to generate hot water. Solar residential heating is becoming more commonplace. Half of the households in some Chinese cities use solar water heaters.